Welcome to the American Institute of Steel Construction's 2024 Forge Prize jury. The Forge Prize since 2018 has been a really unique opportunity for architects to experiment with conceptual design without limit to scope or complexity. So the competition celebrates emerging architects. This year, also architecture faculty and even graduate level architecture students who create visionary designs that embrace steel innovation. The jurors have narrowed it down to 3 finalists who we have here, and they've each won $5,000 and have spent the last 6 weeks working with steel fabricators to refine their designs. So they're presenting those refined designs today, and the jurors will deliberate off screen and then return to announce the grand prize worth $10,000. So it's really exciting. The AISC co-hosts you see here are Christina Harbers, the Senior Director of Education, and I am Jean Homer, the Senior Architect in University Relations. We welcome 3 jurors. I think we'll start with Samantha Flores, is the Vice President and Director of the Innovation and Research Team at Corgan. Reed Kroloff is the Rowe Family College of Architecture Endowed Chair and the Dean of the Illinois Institute of Technology College of Architecture. And Paul Bukowski is the Editor-in-Chief of Architect, which is the journal of the American Institute of Architects. We also thank the 3 member fabricators for mentoring, sharing their expertise with our finalists. We have Tony Diebold with Hillsdale Fabricators, which is located in St. Louis, Michael B. Moore and Thomas Kotniak of Thompson Metal Fab in Vancouver, Washington, and John Pisha of Garby Ironworks in Aurora, Illinois. And these are our finalists, but I'm going to go ahead and just introduce them right before they speak. And I think we can go ahead and start with our first presentation. So Emily, would you like to share your screen?
Okay, thank you so much. So I am going, yes?
Emily, wait, I'll just do a quick introduction of you first.
Gotcha.
No, that's okay.
Go for it.
So our first presentation you can see is Mile Zero, and it's a collaboration between Emily Baker of University of Arkansas and Princeton University's Isabel de la Vieta, and Vincent Edwards, Edmund Harris of the University of Arkansas, West Virginia University's Eduardo Sosa, and Fayetteville, Arkansas based artist Riley Dickens Hoffman. And they partnered with Hillsdale Fabricators, the chief structural engineer, Tony Diebold. Okay, Emily, please take it away.
Okay, thank you so much. We're thrilled to be here to share the project, which is called Mile Zero, a structural steel pavilion for the Greenway. And get something out of the way of my screen here. And the project is a kind of space frame canopy that is supposed to be a public amenity and marker for the Razorback Greenway, which is a 40+ mile multi-use trail system that has a lot of spurs. It's well loved and really well used and a wonderful resource for our area. And the beginning of that trail, the 0 mile of that trail, is at this park, this kind of recreational area called Mount Kessler that includes a lot of mountain bike trails. And it has this little nondescript roundabout that you see in the picture to the right that is the beginning, the Mile Zero of this long trail experience. And the only thing marking it right now is this kind of small bollard that lets people know that they're starting at the 0 mile. So we wanted to also, at the request of some regional and city entities that were interested in celebrating this moment of the beginning of the trail system, propose this piece, which is kind of a public art meets pavilion piece that includes weathering steel as the main material and a canopy that's made out of a spin valence system that I will describe momentarily. That allows for this play of light and shadow and pattern to happen on the ground below it. So you're kind of moving in this circular pattern around this central point. So it provides a place for people to meet up, for people to kind of get information, maps, sit, meet each other, and maybe even take photos after a 40-mile ride. So spin valence is a system that I developed when I was in grad school that is a Kirigami-based space frame system. So Kirigami like origami, except including cutting, so cutting and folding of sheet materials. Um, the system works by creating a pattern of units that is cut into the surface of a sheet materials or sheet steel. And it then folded, each unit folds up out and spins up out of the sheet and then reconnects to its neighboring units to create structural depth. So in this photo, there's a 12 gauge sheet of steel that was about, an eighth of an inch thick. And effectively, it gets turned into something that's 2 inches thick and has quite rigid structural spanning capability. And you can see also below the way that it kind of transforms light as it moves through as well. So from one sheet of material, you end up with two layers that are interconnected with triangulating legs. So very similar to a more traditional space frame, but the way that it works can be a lot more rapid. So here's a plasma cutter with a sheet that's been cut, and then that would end up being unfolded into some pieces like these. So I've made some larger scale prototypes like this, and been able to observe kind of the way that they deal with light and shadow as it moves throughout the day. I've also done some experimentation with um, getting the system to curve. But this proposal would be by far the largest and big public application of spin valence, that it has a slight cone shape to it. So it moves away from the flat application a little bit. It's a horizontal application, and most of the things that I've ever tested have been generally kind of vertical, though it has that capacity to span. And it also kind of scales from smaller units in the center to larger units on the outside. So on the left, you kind of see the base tiling pattern that we started from. And then on the right, you see the way that that spin valence system then is deployed. And that's a kind of aerial view. And then this is a representation of it from the air. Um, so because of the scale shift of smaller triangular units on the inner ring and larger ones on the outside, we get a little bit of a shift in depth as it comes out away from the center. The ring of space frame comes in and bears on this kind of built up beam that becomes like a compression ring. And then that ring bears on these kind of plate-like columns that ring around the central space, and also kind of have an interesting visual effect of sometimes transparency and sometimes become a bit opaque. Through talking with Tony Diebold, and I was able to visit their shop in St. Louis, we decided to divide up the canopy into 20 kind of slices like this. And the end of each slice is just at around 8 feet. So it would fit on a large scale plasma cutter and be able to cut out of a single sheet and then deployed into its structural form and kind of be shipped to the site like this and then assembled on site.
Great, thank you, Emily. So now we will show the preliminary structural evaluation of the system. going from a study of individual units to how the whole system is intended to behave. So first, the other slide, please. So first, to connect to the fabrication aspect that we were just mentioning now, you can see here at the top left the fabrication of a section of the canopy with a paper model. And where we first test holding it only from one end, we can see it already shows higher stiffness compared to a flat sheet. So here is also a model of this and how a flat sheet would be. And then you can see on the bottom left, 3 of these sections connected, just as we were mentioning, connecting up these sections to make the whole surface. But let's take a step back and zoom into the behavior of the individual units as shown on the right. So in a recent scientific publication, we show that we can reliably fabricate the system using steel. We show that the forces needed to deploy the system remain very low, so around 30 to 80 pounds. And this is still something we can do with our own hands. So also in the publication, we tested the system under compression and found it can take up to 1,000 pounds or about 1,400 times its own weight. And that is only for a unit about this size. So I'm showing you here. And I'm sure we can develop the system further and get even better results than that. So here we show the section zooming out, looking at the section of the canopy. We see that the system can behave almost like the space frame we already know, with mostly axial force flow. And the system can then transfer the forces down to the support ring, which in turn transfer loads to the series of columns that we have on the design. And then zooming out even more, we see the system is not only distributing forces down to the support structure through truss action, but when it is fully connected to the final form, it also self-stabilizes with the tension rings that you can see in blue. And of course, this is only a preliminary study, and this concept is successful, we would love to dive deeper and have a more detailed perspective of the structural solution. But for now, we leave you with this concept in mind, and thank you.
Thank you, Emily and Isabel. Did the jurors have some really quick comments before we move on to the next presentation?
I just have one quick question. How does the sunshade connect to the compression ring in the center? Is it just a bolted connection or a welded connection, or?
Well, when we discussed it with Tony, we talked about site welding, because of, but I think that's those are things that we would probably have to iterate with our fabricator and make sure they work well. Yeah.
Okay. That was my question.
Yeah.
I have a question. How wide is the inner ring?
The outer diameter is 60 feet. The inner ring is I don't have the exact dimension off the top of my head. It's 22 or something like that.
Okay. I guess you're having this pavilion which is going to provide shading and hopefully if it's raining, how much of the pavilion is, let's say, practical?
It's not meant for really rain cover the way it's designed right now. It doesn't have a surface on top of it.
Right.
Yeah, it's meant to be kind of an outdoor sculptural piece.
Yeah, but you do have people sitting.
Right. Sure. Yeah.
Sure. And you did say that bollard is the only thing there. So, it would be nice to make it maybe a little more practical is something that I would think. I mean, the idea is beautiful, kirigami, and the technique is beautiful. So there is really a very artistic component to it. But when you go through that whole all that time and effort, it might be interesting to see to make it a little practical.
Yeah. Thank you. Something we also discussed was having some panels at the top that would be transparent, so you can't see it from down up, but you could have that part as well.
Yeah.
One last thing. Sorry, one last thing, and then did you have any break in the testing? Right? Did you have any breakage?
No, we didn't have any sudden breakage, and we tested 5 of each type of unit, polygonal unit, from triangles to hexagons.
Okay, good. Okay, thanks.
I was just gonna suggest that you not put a flat plastic transparent surface over the top because it sort of goes against the whole idea of the metal competition, right? So what might be interesting is to see if there's a way that these things can get infinitely smaller and stack, right? Or there's a variable opening. I would worry less about water. I think that's a lost cause, but I think I might think about shading right now. It's completely uh, uh, perfect circle around there. Maybe it isn't, maybe it's elliptical or maybe it's
Mhm.
something else so that it actually works with the sun to create more effective shading in addition to the density, right? But it's very beautiful. These are all coulda, woulda comics. You have a really beautiful, what I particularly like about it is the dead simplicity of the idea and your follow through on that.
Thank you.
Samantha, did you have any quick comments?
Yeah, I was just gonna say I agree with Reed on everything he just said, not putting the plastic on. Love the simplicity. It's beautiful design. And I also had the same question, Reed. I was curious if you did even study what an elliptical design might give you and how difficult it would be because you wouldn't have the same repeatable um, uh, section. So I was just curious if you tried that at all.
Yeah, we've looked actually this design has went through several iterations ahead of this competition, and at one point it was very not standard. And Isabel and I just we for fabricatability we decided to go with something a little bit simpler this time because we really do want to make this happen for real here. And so I do like I think pulling it into an ellipse is not so out of the realm of possibility. And Isabel and I have discussed it, and she thinks structurally, based on what she's seen preliminarily, that it could work. So yeah.
Great. Thank you.
Okay, thank you. So we're going to have our next presenter. Juan, do you want to go ahead and share your screen, and I'll introduce you while you're doing that. Juan Jose Castellon, his proposal, Building Ecologies installation, is a collaboration among Rice's School of Architecture, the Department of Civil and Environmental Engineering, and the Shepherd School of Music with the support of the Carbon Hub Initiative. And he partnered with Thompson Metal Fab, so Vice President of Business Development Michael Moore and Vice President of Project Management Thomas Kotniak. So Juan, whenever you're ready.
Great, thank you, Jen.
Can you share your screen?
Yes, let me.
Okay.
Share screen. And
all right, whenever you're ready.
Okay, thank you. Well, first of all, I would like to thank the jury and the American Institute of Steel Construction for selecting this project as a finalist for the first prize. It's already a great honor and an amazing opportunity for us. And I would like to start with a bit of the context. Traditionally or historically, steel construction has always been at the forefront of building innovation. If we take reference like Buckminster Fuller or Conrad Waxman or Alexander Graham Bell, they all imagine and materialize beautiful and innovative structures. But what made these projects extremely impactful in the kind of context was that they were proposing also ecological and sustainable building models for our planet. So inspired by this tradition, building ecologies is conceived as a modular and collective building infrastructure that provides shading and shelter while collecting, cleaning, and harvesting rainwater for irrigation purposes, as well as heating and cooling strategies for urban rooftops and public spaces. questions of lightness, prefabrication, modularity, transport, assembly and reuse, converging this proposed kit of parts. And there is an additional layer that is more cultural. It kind of bridges my own culture. I'm from Spain, from Barcelona. We have a strong tradition in metal, especially textiles, metal, and also ceramics. And this project was developed also in collaboration with manufacturing companies in Spain and in Houston, in Texas. So the canopy, in this kit of parts, the canopy, which is the most, let's say, complex structure, was conceived as a space truss, and it was developed. Here you can see one of the mock-ups that was developed in Barcelona, in my hometown. And then the faceted waterproof membrane that collects and cleans the water was developed also there, but also connects with an ongoing technology, an ongoing project and research developed by our Civil and Environmental Engineering department at Rice and led by Dr. Chilin Lee, that basically cleans all the impurities of rainwater, those raindrops that come from the atmosphere, allowing the water, when streaming through the expansive membrane, to be collected with already a kind of level of treatment. And then once collected, the rainwater is channeled through a component-based ceramic column that was also developed in collaboration with ceramic manufacturers in Barcelona, and connects also with the tradition of vernacular architecture that, in former times, these pipes were not PVC or plastic, but actually were ceramic, and we were to bring back this kind of quality in the building components. So these elements, these ceramic pieces, work both as a structural element, but also as a water pipe. And these ceramic pipes were developed, again, with traditional techniques, but also in combination with more digital technologies like robotic fabrication to generate these kind of connections. So the resulting prototype was built and exhibited as an installation at Post Houston, and it was open to the public from October 2022 to April 2023. So here you can see some images of the installation, which was also a very interesting experience because I brought some colleagues from Barcelona and then some crew from Texas, and they were working together in the construction of the prototype, which was a really exciting moment. And then in the way that the resulting prototype came together was also a nice kind of combination of a pre-existing condition on a new nature that was emerging out of this kind of material and structural logic. Since the project, I'm now showing a small video that shows a bit the final result, and you will listen a small sound in the background, because since the prototype was built in an interior as an exterior installation, I was collaborating with the composer and professor at the Shepherd School of Music at Rice, Kurt Stallman, to generate a soundscape that simulates and evokes the sound of raindrops and water streaming. But of course, what we would like is to have this in an exterior experience. I think there is a part that is experiential. So actually bringing another layer of sophistication in the structure is not only functional, but aesthetically pleasant. And also kind of in terms of the perception, something that I really enjoyed, how people was interacting with the piece, basically touching the materials and experiencing this kind of atmosphere. So boosted by this generous award, we are now adapting the concept to an outdoor full implementation, which was the whole purpose of the project. And the proposed site is in Rice University, is the Holistic Garden, which is a urban farming and teaching outdoor space on campus that now demands more, let's say, more opportunities to collect and clean water, to use it for irrigation purposes, but actually also spaces for outdoor teaching and for kind of collective events. So together with Thompson and Metal Fab, with Thomas, but also with Arup Engineering, we have analyzed and simplified and refined this modular system to respond to, for example, wind loads and other functional requirements. We have run a set of several simulations, double checking the kind of feasibility of the project. And also the goal would be to achieve a system that is economic and easy to manufacture, transport, and assemble, and also adapt to different contexts and conditions. So there is a part of the project that involves a kind of possibility to adapt this kind of modular system into more expressive forms. So, and we are using technology for a precise design and manufacturing all of the building components. Together with Thomas and John, we have been going through the project, trying to simplify it, but also to make it more feasible in terms of the connections, keeping the kind of elegance of the proposal, but making it, let's say, also kind of economic and easy to assemble. So, for example, we are now with Thomas, we were, and with John, we were kind of finding the right way to generate these connections in a kind of plate-to-plate, easy way to manufacture and assemble. But we want the steel structure to be the main protagonist while preserving the aesthetic qualities and philosophy of the original concept. So the result is an architecture that dialogues with the natural context and with our community, and explore contemporary and holistic notions of building and sustainable urban infrastructures. So together with my brilliant team and excellent collaborators, we look forward to materializing the project that strives to achieve a balance between economy and beauty, ecology and innovation. Thank you. And here a list of the team with Elliot, my research assistant, that helped me with the images and the development of the project, with John Hand, Arup Houston, and Stephen Donnelly, and also, of course, Thomas and Eric from Thompson Metal Fab that collaborated in this project, and that I really enjoyed. Thank you.
Okay, thank you. All right. So is there maybe one question per juror for Juan?
I just have a quick question. In your initial write-up for the project, you mentioned that this structure could collect water and that it could potentially use that water to feed plants or have a storage basin. And I was just curious if that was part of the final design or if you have plans for that, and how would that manifest itself?
Yes. Of course, it's very important part of the project, but of course, we have a very limited time to present. But if you have seen, there is an elevated floor on top of pedestals. The idea is that the ceramic columns that now are kind of encapsulated by the steel structure, they would collect this water and divert it into water tanks that are equally distributed below the elevated floor. And the ceramic floor is also meant to activate thermally like an active surface. So water and hydronic systems are very efficient systems to distribute homogeneously heating and cooling. And also, well, we are now studying where would be the right place for these water tanks. We are thinking something that is more distributed in a surface rather than the typical water tank that is more stored in a kind of a volume, like the traditional water tanks in New York. Rather, we are looking for something that is more equally distributed and generates other kinds of opportunities also in terms of architecture, to maybe show the water and experience also as a pedagogical and educative process, that you can see the water hitting the membrane, channeling through the column, and then distributing almost like an organic form to irrigate plants and then produce this kind of circular logic.
Thank you.
You're welcome.
Okay, other quick comments, Reed?
Well, Gina, I know you're rushing, so I don't actually have any questions, so I can save my comments. The one comment I'll say, it's a beautiful project in every way, but I'll save a more detailed description for when we get to the comment section, because mine was the same question that was just asked.
Thank you.
You and I are thinking a lot alike today.
We sure are.
Paul?
Can you just take very briefly how much steel is being used? I mean, you're using ceramics, you're using the textile. Just very, very briefly, pinpoint where the steel is being used.
I mean, all the canopy structure was originally space trash structure. So it was all metal tubes. But now with the collaboration with Thomson Metal Fab, we have extended. So now the column actually is also the same metal tubes that reach the ground and they become more protagonist. So all the structure basically is the steel, but we wanted to preserve the qualities of other. And I think something that really makes steel so valuable is the capacity that it has to embrace and integrate other materials. And we feel that is more successful when these materials are hybrid. So the combination with ceramics and with textiles makes but it's always still the material that kind of brings together all of them. So for example, the original pieces now are inside the structural columns. And we didn't make a specific calculation of the amount of steel, but let's say is the main material that we have. And what we are trying is to optimize the amount of material and also generate very efficient connections and very elegant connections. And this is where we are putting the most of the effort together with Thomas and John.
Great. Thank you.
Thank you.
Great. Thank you. Thank you so much. All right. We will move on to Chen. If you want to start to share your screen, and I'll do a quick introduction of you. So we have Usuminoko Chen Shah designing a community art center concept, and he partnered with Garvey Ironworks, the president of customer relations, John Pisha. So Chen, when you are ready, please take it away.
Okay, thank you, and good afternoon. For this final design, my steel fabricator supervisor is John. He's the president of Garvey Ironworks. This project is a public building proposal located in Jimmick Plain in Boston, Massachusetts. The client is a local artist organization. They are looking for a public building design for local art activities. They want a building felt more connected and open to its neighborhood. This is a concept physics model, and my basic design idea is to elevate some glass boxes in the air by a supporting structure with a sense of lightness and translucency. This is a concept image showing my design idea of the relationship between interior spaces and exterior skin. To realize this idea, I think steel is the best choice of the construction material. A regular cubic steel grid system can not only be the structure holding the spaces in the air, but also create the sense of lightness and translucency itself in building and urban scale. During the last couple of weeks, with the advice and help from my supervisor, John, I have revised the steel grid system. The whole system structure consists of multiple module steel cubes. The dimension of each cube is 2 feet in all 3 directions. The key structure of this system is the crossing joist, where steel tubes in all 3 directions meet. So this is the key module steel joist I created with John's advice and help. In the center, there's a steel core, and then there are 4 identical horizontal steel tubes and 2 identical vertical steel tubes. Now I will show the assembling process of this key steel joist. Based on the concept and the steel structure design mentioned above, this is the final design of the Community Arts Center. A translucent building opens to its neighborhood. This is the site plan. The building creates and encourages more shortcuts when people walking around. This is the ground floor plan. Office and storage spaces on this floor. On the ground floor is for public open space, 2 staircase by the sides, elevator core in the center. And on the second floor, there are 2 glass boxes as interior spaces. Similarly happens on the third floor. 2 glass boxes are as interior spaces and an open space. On the top floor, the top terrace along the west side, it's an enclosed space connected with the space below. This is the south elevation in day and night view time. From the south facade, people outside can sense the interior space. This is the north elevation views. The same from the north facade, people outside can sense the interior space inside. I revised and lifted up all the glass boxes to open the ground floor to the neighborhood. The blue area are the 3 enclosed entries on the ground floor to the glass boxes upper levels. For the rest space on the ground floor, the steel grate system doesn't enclose the space. It defines the space. So people can walk through, stop by, and get together on the ground floor. The space is part of the building and also a part of public open space of the neighborhood. These are west and east elevation views. From west and east facades, people outside can sense all the interior spaces. Since the center core blocks the sunlight, space 1 and 3 are covered with shade most of the daytime. So this is a perspective view in space 1. People inside can sense the surroundings outside. Another view in the same space from the opposite. For sure, there will be direct sunlight in a day. Now I will show the sunlight shadow variation in the space from morning to afternoon. So this is 6:30 a.m., 8:50 a.m., noontime, 3:10 p.m., and 5 p.m. So the direct sunlight in space 1 and 3 only happens in early morning and late afternoon. If the art material is very sensitive to the sunlight, or if there is some immense need all-time shade environment, my solution is to install shade curtains to block the direct sunlight. Space 2 and 4 always get sunlight all day long. Sometimes maybe it's a good thing because the shadows of the steel grate system may create a more artistic environment in the space. Here's a long section cut from here. If we zoom in this moment, we have this view in the space 3. People in the open space and on the terrace can walk around for the neighborhood views, and people inside the glass box can sense the surroundings outside. Here's the short section cut through from here. If we zoom in this moment, we have a view in the same space. People on the terrace can attend what's happening in the space below. As an important part of the building structure, the steel grate system combines trusses, posts, beams, the vertical and horizontal structure cores all together for the structural stability. For the architecture design, with a sense of lightness and translucency in building scale, the steel grate system connects the interior spaces with its neighborhood. And that's all. That's my design. Thank you so much.
Thank you, Chen. Are there any quick questions from the jurors or comments?
It's a very beautiful project, Chen.
Thank you.
Just wanted to say that from the front, the kind of continuous nature of the way the steel works makes it visually very beautiful. One simple question: your your slide together connection. Are you anticipating that those are bolted as well?
Yes, both, I think.
Okay.
Yeah, I'll just add, I also appreciate the design of the veil system. It seems to really be conducive to your idea of letting the community in and giving some visibility to the interior, and then also back to the exterior. I think what I would like to see on that night shot is, you know, a view of some of the art pieces, because if you could see in, it would just be really fascinating to see all the pops of color coming from that, and really kind of jazz up that sexy night shot.
Thank you.
Did you have a quick comment? Okay. Oh, you're muted.
I'm good.
Okay. All right. Well, those were 3 really great presentations. Thank you so much. Right now, Zach is going to send the jurors and me into a separate room, and Christina will be your host, and we'll see you in a few minutes.
Thank you.
The jurors will get a little invite on their screen that you'll All right. Well, while we're waiting, I was curious to know from our fabricators, if you're able to speak for a couple minutes each, can you tell us about your experience collaborating with these architects, or if you wanted to comment on some of the presentations that you saw today? Tony, I don't know if you're still on and available to talk about your experience.
Yeah, I'm still here. Working with Emily was kind of a stretch for me because, you know, being an engineer, I like straight lines and everything was, you know, cattywampus. So I thought it was, you know, at first glance, I was confused by what I was looking at. And, you know, once she kind of explained the whole spin valence concept to me, I thought it was pretty innovative and seems like it could be a really interesting structural piece, but also very artistic at the same time. So, you know, when we met, we discussed constructability first and foremost. You know, we talked about tolerances and, you know, lateral stability and, you know, the use of weathering steel, because coating, you know, getting some kind of high performance coating and all those little cracks and crevices just seemed like that would never work very well, and you're going to end up rusting everywhere anyway. You know, we talked about the size of the units, given, you know, typical plate material sizes and machine capacities. You know, she was able to come to St. Louis and meet with me, and I think that was pretty helpful. I don't know if anybody else had that experience, but I prefer meeting in person, so that worked out really well for me. And yeah, and you know, I talked to her, and we intend to continue to support her and Isabel's design development as this design becomes a real project. So we intend to stay in the loop and help them with budgeting and more constructability as the design develops. So it was a good experience. Thanks.
All right, that's great to hear.
Thank you so much, by the way. I'll say that.
Yeah, no problem.
It was incredible to get to also tour their facilities. So that was really amazing as well.
And I'm not sure if any of our Forge Prize participants have ever actually met in person and toured the shop of our fabricator mentors. So that's pretty amazing. Tony, you mentioned that, you know, this is obviously not a structurally driven project. You know, we have architects here that are really, you know, pushing it with their designs. And this was a great example of that. I don't think any of the three projects that we saw today were like really straightforward. Everyone's really, pushing it in terms of design, which is exciting. If anyone from Thompson Metal Fab wants to talk about their experience, Michael or Thomas.
Yeah, I guess I can certainly comment to that. I mean, it was a very good experience, right? It kind of reminds me of of the design build projects that we often do in close collaboration with the engineering outfits, right? It's just that in this case, it was kind of spiced up by having the architect as a part of the collaboration process, right? So that way you basically get to be a part of the design and the architecture as it develops, right? So you have the chance to influence the main aspects that if done right, then later on in the production process, make those projects a success, right? So with Juan and John, I mean, we basically very early arrived at the subject of the modularity and the repeatability aspects for the production that ultimately kind of determine the fabrication efficiencies, right? And then the modularity of the system allows for scaling. It allows for the efficiencies through the fabrication, through through the transportation, and through the assembly, through the erection in the field. I think one of the one example would be like a discussion about how you put these things together in the field, right? Whether you go for field welding or just bolting. I think we all pretty quickly settled at the no field welding option. It's kind of like if it's done right, then build it in the shop, and then in the field, don't strike an arc in the field, right? The other aspect that is really good or enjoyable about these projects is that it kind of seems a common theme across the board for all three of these presentations is how the architects are combining the various materials. It's not steel only, right? It's steel for the structural aspects, but then there's the other materials that are involved in different ways, while you basically make a really good use of the pros that the different materials offer. So that was really really unique and enjoyable aspect of this project. So on our side, certainly a great experience. Really good collaboration with Juan and John, and hope we can take it to an end.
All right, well, that's good to hear.
Thanks for the opportunity.
Yeah, I'm so glad to have you participating.
Thank you,
then, John, if you wanted to say a few words about your experience and what you saw here today of the design.
Yeah, just wanted to say I thought that all three of them were wonderful ideas and beautiful designs. I had a lot of fun with reviewing Chen's design because it was building and that's what we do. So that was nice for us. I thought his use of the material in the neighborhood was remarkable, so that it could be viewed by everybody and appreciated by everybody, and also be useful for the community. So I just thought it was a wonderful design, and constructability wise, it would be something that could be modular and built in a shop and delivered at the job site, and erected in not the easiest way, but pretty close. It was quite of an experience, and I enjoyed it quite a bit. So thank you.
All right, thanks, John. I think that seemed to be a theme in all three, was modularity that was explored, which is interesting.
if anyone wanted to talk about that, did you have that in your head in the very beginning, or is that just something that it seems to be something that architects really are interested in, modularity? Is that a theme in all of your work?
Oh, certainly. I mean, I think having done a lot of prototyping in the past with digital cutting, and in my shop we have a capacity of like a 4x8 sheet of material. And so modularity, to build anything bigger than that, we have to like get modular. So absolutely, always kind of thinking about how the parts come together.
Yeah, I think there is a question that relates to economy of means. There is then the other aspect that is differentiation, right? Because you have modularity, but you don't want a boring repetition of a module. Or let's say there are things that we can propose now in contemporary scenario with the available technology. So I think it's a question of how balancing the kind of economy of means by using a modular system, and at the same time a more responsive and adaptable system to that can kind of incorporate different questions, environmental or aesthetics or spatial.
All right, it looks like our jury is wrapping up. They're almost done. Check on them for a second. Maybe another minute. It was interesting contacting some of our member fabricators to see if they'd be interested in this opportunity, because it is so different than what we typically do, at AISC and also as structural steel fabricators. And I noticed Thompson Metal Fab in particular replied with like 4 people copied on it, like, you can use all of us, like we're all really interested. And I really appreciate that. I don't know if all of you, your whole team, participated, or if Tomas, you were the lead on that.
We kind of took the lead on it on the project management side of things, because that's who we normally have, work with. Is kind of the connecting bridge between the designers and the detailers and the shop. So we kind of approached it in a similar manner how we would the other projects that we do.
And any of our fabricators, if you were to talk to another fabricator about this experience, what would you say to them? What would you warn them about? What would you like? Would you recommend this to them?
I think it's great to be involved. My whole office and shop, my brother runs the shop for us, and he got excited about it. And the guys that program all our machines actually did a paper cardboard model of Chen's design, part of it. And without me even talking to him about it, it was just me sharing the pictures of Chen's design. So everybody got real interested in it, and it was neat for us because, again, we usually just deal with engineers and don't get to talk to architects very often. So it was a welcome change.
You don't know how lucky you are, John.
All right. Well, are we ready? Yeah. Jean, what's going on?
Yeah. So Reed is going to take over the announcement of the winner.
Well, thank you, Jean. First of all, I want to thank all the folks like John and the fabricating experts who made this possible for the competitors. It makes such a huge difference, and I know all of you run businesses, and so this is not something that is going to go on the profit side of the ledger in a traditional sense. But listening to John just then, it sounds like it may go on the profit side of the ledger in another way. that has a longer lasting effect. And so thank you to all of you for making this possible. In the same way, of course, thanks to AISC for underwriting this and doing something that's really meaningful for both the fields of architecture and steel fabrication, for helping us push boundaries in what we do in these fields, and in encouraging meaningful collaboration, which you've accomplished. Having said all of that, we're going to run out of time in a minute, so I'm going to jump in and say we loved all three projects, each for different reasons. And Jean's been taking great notes and will be able to articulate those reasons to each of the competitors. All of you deserve congratulations. I know that sounds like just kind of standard dean talk, but in fact, it's really true. And I think all of the jurors would would confirm with me that we spoke about each of the projects in a very different way and articulated the things about those projects that we thought were strong, and got closest to the spirit of the competition. But being forced by Jean cruelly to have to choose only one at the end of the day, we decided that Arkansas is going to be a big winner in the long term, because the shade structure we thought was remarkably innovative in its structure, in the way that it took steel and used it in such an interesting fashion, both the unfolding and the stacking, and how it seems to be something that can possibly have other shapes or add things to it. Don't bring anything that's not steel into it. That we thought that it had great promise for steel as a building material. But to both Juan and Chen, your projects are terrific. And have Chen, yours has great promise. Juan, yours is super sophisticated. And we all want to be underneath it when it rains. So we thank you for what you've done, and we think everybody did excellent work. Paul, Samantha, did I do okay? Did I leave anything out?
Did a great job, and everybody did a wonderful job. These projects were absolutely beautiful, so great job participating.
Paul, you want to jump in with anything?
Yeah, I think at Architect we'll be writing about this, so we'll be able to get more information from Jean, and we'll definitely be showcasing all the finalists and the winner too.
Well, that is great news for everybody. So thank you for that. Thank you really to all the finalists and entrants, the jurors, the mentor fabricators for all of your work. We know it's a lot of work and a lot of time for the Forge Prize competition. We really just love to see innovative ideas, see where it's headed regarding structural steel, and literally to forge the connections between architects and fabricators. It's a great thing for architects to really connect with those who have expertise in making the steel material work. So thank you so much. All right, but that ends our program. Everybody, give yourself a hand.